Okay, excuse me. Ready for problem 26. Let me find, there we go. Looks like a story problem. After an injection, the amount of medication A in cubic centimeters in the bloodstream decreases with time in hours. Suppose that under certain conditions, A is given as the function below, where A naught is the initial amount of medication. Assume that an initial amount of 60 cc is injected. Complete parts A through D. So this problem is about giving medicine to someone, being injected. The initial injection is 60 cc's. And this is an equation that involves time. So this tells us at any point in time, we can plug in a time for t in order to tell us how much medication is still in the body. This A with a little zero here, this is called A naught. This is going to be, I think, the initial amount of the medication, how much it started with, which actually they tell us it's 60 cc. So A naught is actually 60. We can plug in a 60 here. And then they have a bunch of questions. So let me write down the equation, and then we can start trying to answer these questions. So this is 26. So the question is A of t. So instead of A naught, I'm going to put 60 in, 60 over t squared plus 1. So the first question is they want us to find a bunch of the values. So this is the amount of medication at time 0, at time 1, at time 2, at time 7, at time 10. I assume these are hours. Yeah, in hours. So they're asking us just to determine a bunch of the amount of the medication in the body after a certain amount of time. So I'll just write these down. A0, A of 1, A of 2, A of 7, and A of 10. So basically, we have this equation. We want to find the amount of medication at 5 different times. So you plug in 0 for t up in here, and you get 60 over 0 plus 1. That's pretty straightforward, 60. And of course, the units are cc's. You plug in 1. 60 over 1 squared plus 1 is 60 over 2. You plug in 2. 2 squared is 4. 60 over 5. It's 12. Plug in 7. 7 squared is 49. 49 plus 1 is 50. So it's 6/5. And you plug in 10. 10 squared is 100. 60 over 101, which doesn't reduce actually. So let's enter these answers. Hopefully they're all correct. So this is 60, and of course the units are cc's. And then at 1, it's 30 cc's. And then at 2, it's 12 cc's. And at 7, it's 6/5. They want it as a decimal. Actually, this is 1.2. I think I can do that in my head. And 10 is 60 over 1.1. Definitely going to use my calculator. It's a little over 0.6, but 60 divided by 101. Is it around to the 10,000th? That's like 4 decimal places. Wow, seems crazy. So my calculator says 0.5941. Now, next part of the question. Find the maximum amount of medication in the bloodstream over the interval 0 to infinity. So when is at what time is the maximum amount of medicine in the bloodstream? We're wanting to find a maximum. We're wanting to find out when this function is maximized. How do we find maximums? Well, the way we find maximums is we can take the first derivative, set it equal to 0, find that critical point, and see if it's a maximum. So I need to take the first derivative of this function. So here's the original function. Let's just go ahead and do the quotient rule. Low, d high, derivative of the top is just 0. Minus high, d low, derivative of the bottom, t squared plus 1 is just 2t, over the bottom squared. If we simplify it, so there's the first derivative. Hopefully you can see now, if we set this equal to 0, the solution is going to be maximum is going to be when the time is 0. That actually makes sense. You know, you put the medicine into the body, and then the body begins to absorb the medicine. So I believe it's going to be 0. And the amount, we already figured out when you plug in 0, it's 60. So it's 60 cc's at time 0. So sketch a graph. Well, has to be these first two because the time starts out at 60. If we look at our points, it's definitely not B, because like at time 1 should be 30, which it is. Time 2 should be like 12, just to show you B. Time 1 is definitely not 30. So this is definitely the answer. According to this function, does the medication ever completely leave the bloodstream? In other words, is the medication ever equal to 0? We can just look here. If you look at this equation, can you ever enter a time for t to where this whole thing equals 0? And the answer is you actually cannot. Interesting thought to think that you can put in a t of like a year or 10 years, and this number will be super, super, super small, but it'll never be 0. Of course, this is a model. A model means a model tries to imitate what happens in real life. I wonder if in reality your body actually gets rid of it all. But the model says it doesn't quite. So there is always some medication in the body. That's an interesting question, sort of. All right, number 27. All right, here's a little bit of a new topic now. You notice up until now, they've called it relative extrema. When we say maxes and mins, what we've really been looking for are relative maximums and minimums. Now we have a different concept. Notice here, have to find the absolute max and min. So I got a function. Now when you are looking for absolute maximums and minimums, they almost always have to give you the limits or the parameters of where you're looking. So in other words, here's this function, and they're saying we're just looking when x is from 0 to 4. Greater than or equal to 0, less than or equal to 4. So we're only looking at a certain range, and within that range, we're saying what's the maximum value of the function. So let me write down this function, and let's take a quick minute to talk about the philosophy of finding absolute maximums and minimums. So this function is f of x equals 4 plus x minus x squared, and x, they're saying, has to be greater than or equal to 0, less than or equal to 4. So let's talk about this. So it's almost like for this problem, let me just do a little talking with the graph, and then we'll actually solve this. Think of 0 and 4 here. So we've got a function, but we're only looking at the function in between 0 and 4. Although actually we're going to include 0 and 4. But here's where we're looking. And what they're asking us is, from 0 to 4, what's the maximum value of this function? Now, a couple of different things can go on. A lot of you, this might be the obvious one. If there's a relative maximum inside the function, obviously that's the maximum point. But what if the graph is like this? What would be the maximum point? Well, actually, the maximum point would be right here at the edge. What if the graph was like this? Where's the maximum? Over here at this edge. So because of that, here's the way you do these absolute maximum minimum problems. First step, according if you're looking for a max or a min. So find your max or min that are in between your two, I'll call them limits, right? So in a minute for this problem, I'm going to look for any maximums or minimums that are in between when x is 0 and x is 4. Now, I'm going to say at that point, you compare the relative max and min. By that, I mean what you just found. We'll call this relative max and min. I could say find the relative max and min. Compare the relative max and min, and I'll call them endpoints. So these we call the endpoints, 0 and 4. So in other words, if this is our graph, you compare this point, and this point. You compare the value of the function, and you see which one's the largest. And the largest one's the absolute. So if I had this graph, and I compared the value of the function here, and here, and here, obviously, this is the highest. That's going to be the absolute max. But what if I had this function here? I'm going to compare this point. There is no max or min in between, So I simply compare the endpoints, this point, and obviously that would be the absolute max. For this last one I drew, once again, there's no max or min in between. Let me just for fun, what if we had something like this? And I came in here. What if this was my graph and I'm looking between here and here? So I'm going to compare the endpoints and any maximum or minimums in between. So I would compare this point and this point. Of these 4 points, which is the largest value? This one. So even though we have a maximum in between, the actual value of the function at this relative maximum is less than at the endpoint. So that's why it's really a two-step process. You have to see if there are any maxes and mins in between the endpoints, and then compare that with the endpoints, and you just look for the largest value. Pretty straightforward. So let me rewrite this function, and we'll just do this one. So once again, here's the function we're looking at. I'm going to sort of rewrite it in the normal order we do. And once again, for these absolute max and min problems, they have to tell you where you're looking at x. In this case, we're looking at x from 0 to 4. So first step, find relative max and mins. I'll call it in the region. In this case, the region's x is 0 to 4. Why do you do that? You take the first derivative. How do we find maxes and mins? You set the first derivative equal to 0 and you solve it. So you'd have negative 2x equals negative 1, x equals 1/2. Now be careful, because now this is possibly a max or a min, but you have to make sure your value of x is within the region, within your range, and it is. I'm looking from 0 to 4, it's 1/2. So now, that's the first step. The second step is you just look at the values of the function. And honestly, at this point, I don't even know if this here is a max or a min. And you know what? I don't really care. I don't have to spend the time to decide that, because all I'm going to do now is I'm going to compare. So here are my, what I call my endpoints, and be careful, you go back to the original function. I'm not using the derivative now, the original function. For the endpoints, one endpoint is 0, so I plug in 0 in for x, and the value of the function at 0 is 4. The other endpoint, I plug in 4 for x. In this case, a little more math, so it's minus 16 plus 4 plus 4. So far, if I look only at the endpoints, it looks like when x is 0, the function is larger. Because when x is 0, the function is 4. When x is 4, the function is negative 8. But now I have to compare also any relative max and mins. So then I take this one and I plug 1/2 into the function. So this is going to be negative 1/2 squared plus 1/2 plus 4. So this is 1/4, negative 1/4 plus 1/2 plus 4. 1/2 is like 2/4. So this is 1/4 plus 4. This is like 4 1/4. Now you compare these three values of the function. Which one is largest? Since we're looking for the absolute max, it looks like this is the largest. Therefore, when x is 1/2, that's the absolute maximum. If they ask us for the point, it'll be like 1/2 5/4. All right, so absolute maxes and mins, not that hard. The absolute maximum value, so now they're asking, what's the absolute maximum value of the function? I said it's 5/4, and it happens when x is 1/2. I didn't like something. Oh, they want it in decimals. Nice. So 5/4 is 1.25. It seems sort of crazy. And 1/2 would be 0.5. Huh. Now, did I mess up? Oh, yeah. 5/4 is 1 1/4, 1.25. And it occurs at 1/2. I assume this is the graph. I wonder what it looks like. Oh, you know what I did? 4 1/4 is 4.25. Oops. You probably saw that all along. You're probably screaming at me. All right. Then the minimum, now the point is there was only, so the same thing. For the minimum, I do the same thing, except now I look for the smallest value of the function. So I compare 4, -8, and 4 1/4. Obviously, -8 is the smallest value of the function. So x equals 4 is the absolute minimum. So that would be 4 -8. So the value of the function is -8, and it happens when x is 4. It actually happens at one of the endpoints, the maximum point. All right, so now I'm going to have us do another one. Now, it's funny how if we look at the graph, sometimes you can look at a graph, but the tricky thing is, now here, we can probably look, well, it's not going to be real precise, because look. So we're going from -1 to 2. So it starts here. It goes up, comes down, and goes up here. You know, obviously the maximum's here, but the minimum, it's hard to tell. Is it here? Is it here? Or are these both the same? And even if the maximum is here, we have to get the exact value. So we have an idea of what's going on. Looks like the maximum is going to be probably at x equals 2. But the minimum, you don't know for sure. We're going to have to do the math. So let's go ahead and do the math part of this. And then we'll have our answers for sure. You can look at the graph and get a pretty good idea, but I'm not sure you're going to be able to get the exact mathematical answers correct. So this is 28. So f of x equals 5x cubed minus 5x squared minus 5x plus 7 and -1 to 2. All right, let's look at this. So once again, the first step is see if there's any maximums or minimums, any relative extrema in between x equal to -1 and 2. So I got to take the first derivative, 15x squared minus 10x minus 5. I set that equal to 0 and I solve. I can divide both sides by 5. And I get 3x squared minus 2x minus 1. This is the trinomial. I want to see if it factors. The way I do factoring trinomials, I do product is -3. Sum is -2. Looks like the factors would be -3 and 1. So the way I do these, I bring down these first and last terms. I split this up into -3x plus x. Factor out these two, factor out a 3x, x minus 1 plus x minus 1. The x minus 1's factor out into 3x plus 1. So there it's factored. Now to solve it, I look at each parenthesis. The solution for the first parenthesis is 1. This one is -1/3. And just for a sanity check, if you're taking a test or problem like this, I could go back and look at my, since they gave me the graph, make sure I didn't mess up. Looks like -1/3 and 1. Looks like I've done the math correctly. So now, that's the first step. Step 2, I just start comparing the values of the function. Let's do the endpoints first. So f of -1. So let's do this. 15. Once again, whoops. See what I did? I was looking at the derivative. You have to go back and compare the actual function. 15 times -1 squared is -1. Minus 5 times -1 squared is just 1. Minus 5 times -1 plus 7. -5 minus 5 plus 5 plus 7 looks like 2. F of -1 is 2. And once again, if I wanted to, I could look at my graph and confirm it. The second endpoint is 2. So I could plug in 2 into my original function. So I'm going to have 5 times 2 cubed, which is 8, minus 5 times 2 squared, which is 4, minus 5 times 2 plus 7, 40 minus 20 minus 10 plus 7, -30, 10, 17. Now I have to go and check my relative max and mins. So the first one I'll do is f of 1. So 5 times 1 cubed is 1, minus 5 times 1 squared is 1, minus 5 times 1 plus 7. 5 minus 5 minus 5 plus 7, 2. Now, I also need to do the other max or min, which is going to be sort of a pain because it's -1/3. It's going to be a fraction. So 5 times -1/3 cubed, 3 times 3 is 9. -1/3 cubed is -1/27. -1/3 squared is 1/9 minus 5 times 1/3 plus 7. This is getting very messy. -5/27 minus 5/9 minus 5/3 plus 7. I wonder if it asks for these answers in decimal or fraction. So if I want to combine these, I need a common denominator of 27. Multiply this fraction by 3/3 minus 15/27 by 9/9. Let's leave this for now. Or actually, 7 times 27, I think is 189. So 189, it's actually minus 60, minus 65. 124. If I convert that into a decimal, 4.593. So now I have 4 values of the function to compare. For the endpoints, I got 2 and 17. From the maxes and the mins, I got 2 and around 4.6. So just looking, the minimums, I have 2 different points that gave the lowest value. The lowest value is 2 at -1 and 1. The highest value looks like it's here at 17. So it looks like that's the max. The min, there's sort of a tie. So we looked at that graph. We thought maybe that would happen. And that's what the math actually shows us. So let's try and answer the questions. Absolute maximum. There's only one maximum. It's when, and it was 17, and it happened when x is 2. See, the thing is, we could tell that from looking at the graph that it's 2, but it's hard to know precisely the correct number here without doing the math. Actually, turns out it's 17, which 14, 16 looks right, but would have been hard to just look and see. Use the comma to separate the answers as needed. So actually there are, the minimum is 2, and it occurs at -1 and 1. All right. Now here I think is an absolute max or min problem, but it's in the form of a story problem. And an employee's monthly productivity M in numbers of units produced is found to be a function of the number T of years of service. So in other words, once again, they're realizing that how well or how much work a person does depends upon how long they've worked. Sort of makes sense. For a certain product, a productivity function is shown below. Find the maximum productivity in the year which it is achieved. So they've come up with an equation, a function, that relates how much work a person gets done versus how long they've worked. Sort of makes sense in the real world. The longer you've worked, hopefully the more efficient and the more work you can get done. Now in this case, you notice the limits are, the time is 0 to 40. So they're saying 0 years is when a person first starts, and then 40 years is maybe when they retire. So they're saying, okay, here's an equation that describes how much work a person gets done according to how many years they've worked. Go in there and find out which year they have the most productivity. Because of course, as you get older, you have more experience, but then you may not be able to work as hard or as strong. So probably somewhere in between 0 and 40 is when your maximum amount of work is being done. So let me write down this function, and then we can solve it. So this is number 29. M of t equals negative 4t squared plus 232t plus 100. And they're saying we're going to look when the time is between 0 and 40 years. So here's this function. Here's where we're looking. So this is where just an absolute maximum problem. It's the same 2 steps. I have to first see if there's any relative max or min. In this case, a relative max in between here, and then compare that to the endpoints. So I need to take the derivative of this, negative 8t plus 232. Now to find a critical point, or the max or the min, you set that equal to 0. End up with t equals 232 divided by 8. And if I grab my calculator, it's 29. So now that's the first step, find any relative max or min. And the second step is you just compare the endpoints. Once again, be careful, it's the original function. First endpoint is 0. Second endpoint is 40. And then, I'll just write it here, the relative max or min we have to check is when the time is 29. 0 is pretty easy. First term is 0, second term is 0. 40, I have to do the math. Negative 4 times 40 squared, which is 1600, plus 232 times 40, plus 100. So 232 times 40 equals minus 6400 plus 2980. So this is how many units the person does. So the first year, not a whole lot. Look how much more the person does after their last year of work. But what happens after the 29th year? Negative 4 times 29 squared plus 232 times 29. Definitely need to use my calculator. So 3464. So here is the amount of work the person does. In 0 years, 100. After 40 years, 2080. In between, at 29, 34, 64. So actually, that 29th year is when he's getting the maximum amount of work done. So it's achieved in year 29. And they're going to probably ask the amount 3464. All right, I'm going to hold off on this one. Start the next video. This one, it's not an absolute maximum. It looks like to me it's just back to a normal kind of first derivative problem. So we'll stop now and we'll start again here with the next video.